Imagine a time when the very nature of light was a mystery. An era when the stars and planets whispered secrets that only the most daring minds sought to uncover. On November 21, 1676, Danish astronomer Ole Rømer stood before the world and announced something extraordinary. He had measured the speed of light. It was a revelation that would challenge centuries of thought, propel humanity into a new scientific age, and prove that even the invisible forces of nature could be understood through the power of observation and reason. But how did he do it? And why does this discovery matter so much? Stick around, because by the end of this video, you'll not only understand the genius of Rømer's work, but also how it paved the way for the technologies we rely on today. Everything from GPS to fiber-optic internet. The 17th century was an incredible time for science. The telescope had recently been invented, and astronomers like Galileo and Kepler were transforming our understanding of the cosmos. But light, one of the most fundamental aspects of our universe, remained elusive. Was it instantaneous, reaching us from the stars in an instant, or did it have a finite speed? For centuries, philosophers and scientists debated the question. The Greek philosopher Aristotle believed light traveled instantaneously, while others, like Empedocles, argued it had a finite speed. However, there was no proof, only speculation. Enter Ole Rømer, a brilliant Danish astronomer working at the Paris Observatory. Rømer wasn't just interested in the stars, he wanted to answer the big questions about the universe. And in 1676, he set his sights on solving the age-old mystery of light speed. Rømer's breakthrough began with a moon, Jupiter's moon Io to be precise. Io, one of the 4 largest moons of Jupiter, had been discovered by Galileo in 1610. Astronomers had noticed that Io's orbit around Jupiter was incredibly regular, like the ticking of a cosmic clock. By observing Io's eclipses, when it passed into Jupiter's shadow, they could predict its movements with remarkable accuracy. But Rømer noticed something peculiar. The timing of Io's eclipses wasn't always consistent. When Earth was closer to Jupiter, Io's eclipses seemed to happen slightly earlier than predicted. When Earth was farther away, the eclipses were slightly delayed. This discrepancy wasn't random, it followed a clear pattern. Most astronomers at the time assumed the issue lay with their calculations or observations. But Rømer had a bold hypothesis. The variations were caused by the finite speed of light. As Earth moved closer to or farther from Jupiter in its orbit, the light from Io had to travel different distances to reach us, causing the apparent delay. To test his theory, Rømer meticulously tracked Io's eclipses over several months. He compared the predicted times of the eclipses with his observations and calculated how much the timing varied as Earth's distance from Jupiter changed. The result? Rømer determined that light took approximately 22 minutes to travel the diameter of Earth's orbit, a staggering distance of nearly 300 million kilometers. From this, he estimated the speed of light to be around 220,000 kilometers per second. While this figure wasn't exact, modern measurements place the speed of light at just under 300,000 kilometers per second. It was groundbreaking. For the first time in history, someone had provided a quantitative measurement of light's speed. Rømer's discovery was a turning point in science. It proved that light wasn't instantaneous, and that even something as intangible as its speed could be measured and understood. This revelation had profound implications. It challenged long-held beliefs about the nature of the universe and inspired future generations of scientists to explore the mysteries of light and energy. Isaac Newton, who was developing his theory of optics at the time, would later build on Rømer's work. And centuries later, Albert Einstein would use the speed of light as a cornerstone of his theory of relativity. But Rømer's contribution wasn't just theoretical. By understanding the speed of light, humanity gained a new tool for measuring distances in space, leading to advances in astronomy, navigation, and communication. Today, technologies like GPS and fiber-optic internet rely on principles that trace their origins back to Rømer's discovery. Although Rømer's work was groundbreaking, his name often fades into the shadow of scientific titans like Newton and Galileo. Yet, his contribution remains invaluable. proving that even the most enigmatic mysteries of nature can be unraveled through meticulous observation and rational thought. Rømer's work also serves as a reminder of the power of curiosity and persistence. He didn't have advanced tools or modern technology, just a telescope, a sharp mind, and a determination to uncover the truth. And his discovery, presented to the world on November 21, 1676, wasn't just a scientific milestone. It was a testament to the idea that human ingenuity has no bounds, that with enough effort and creativity, we can measure the immeasurable and understand the seemingly incomprehensible. So why should we care about Rømer's work in 2024? Because the principles he demonstrated, the importance of observation, the power of questioning assumptions, and the value of curiosity are as relevant today as they were nearly 350 years ago. Rømer's discovery laid the groundwork for the technologies that connect us, the tools that guide us, and the science that helps us understand our place in the universe. Without his work, our world might look very different. And his story reminds us that every great achievement starts with a simple question: what if? Ole Rømer's measurement of the speed of light wasn't just a scientific breakthrough, it was a triumph of the human spirit, a moment when one man's determination to understand the universe changed the course of history. As we continue to explore the mysteries of our world, let Rømer's story inspire us to look up, to ask questions, and to never stop chasing the light. If you're fascinated by the story of Ole Rømer and want to dive deeper into the history of light and its role in science, check out the links in the description and the first pinned comment. We've included some amazing books that explore this topic in detail and can help you learn even more. Don't forget to like this video, share it with anyone who loves history or science, and subscribe to the channel for more incredible stories that shaped the world. Thanks for watching, and we'll see you in the next video.